Welcome. So in this week, we will continue to talk about big data processing. So we'll get introduced to Apache Spark. So we'll take a brief look into the Hadoop ecosystem for processing big data and see where Apache Spark sits on the Hadoop ecosystem. Then we'll talk about Apache Spark features and then the Apache Spark architecture and ecosystem. So let's get started. Apache Spark is an open source framework that is a unified engine that takes care of different types of processing, batch processing, stream processing, SQL workloads, etc. So Apache Spark, what it is a fast in-memory data processing engine. So it's not a file store, it's a data processing engine that allows data workers to efficiently execute streaming or machine learning workloads or SQL workloads that require fast and iterative access to data sets. So the computational engine can schedule and distribute application consisting of many computational tasks across different worker engines. So Apache Spark by nature is distributed. So it can be the workload can be distributed across different worker machine. So it's a unified engine. It's a unified data processing engine for all the large scale data analytics workload that we have, be it batch processing or stream processing. So it natively supports distributed programming to manage parallel processing as well. So before we jump into the Apache Spark ecosystem, it helps us to understand the Apache Hadoop ecosystem. Okay, so here is a overview of the Hadoop ecosystem, which consists of the Hadoop file system, HDFS, that stands for Hadoop Distributed File System. And then on top of it, there is Hadoop Yarn, which is yet another resource navigator. Then the Hadoop MapReduce, and then there is a lot of aspects like the Pig, Hive, Mahout, which we will talk about it. So within the Hadoop ecosystem, we are going to in this module concentrate on Spark. So Spark consists of its core engine, which is called Spark core, and then on top of it is built Spark SQL for doing SQL workloads, Spark streaming for streaming data, for graph processing, graphics, and for running all the machine learning libraries, Spark MLlib. So as I said, before we dive into the Spark, Apache Spark framework itself, it's important to understand Apache Hadoop ecosystem. Hadoop is a software framework that was used to store and process big data. So the Hadoop ecosystem consists of two main components. The first is HDFS, which stands for Hadoop Distributed File System. So this is just a distributed storage system. The whole idea being the file storage is distributed according to a master-slave architecture. The name node was the single master node and there were multiple slave nodes. So all of the data, big data was distributed in a distributed way with regard to a master node and multiple slave data nodes. Another very important component of the Hadoop framework is what is called MapReduce. So this is a very important programming paradigm that used to process big data that used key value pairs. So what exactly MapReduce did was it essentially converted all workloads into two steps, mapping step and a reduce step. So the MapReduce is a programming model within the Hadoop framework that was used to access big data stored in the Hadoop file system. Okay, so the mapping step is what it did was you can see a very simplified view of it in the visualization stored. It took the input data, split it into smaller blocks. So each block can be assigned to a mapper for processing. So it helped to parallelize multiple of the big data processing. So reducing is essentially the aggregation step that happened. So after all the mappers finished processing, data was shuffled and sorted before passing on to a single reducer. So all map values that had the same key was assigned to a single reducer which aggregates the value of that key. So here if you look at it, so if we were to count the number of words in this document, right? So there are multiple words. So this is a simplified example. So mapping operation, what it did was it distributed, it sort of split the file into multiple files which are key value store, which can be parallelly processed. All right. So by processing it parallelly, so it knows that the key ONE occurs once, the TWO occurs once, and again ONE once. So during the reduce phase, what happened was all the keys which correspond, which all the common keys were sent to the same reduce operation, so that the aggregation sort of can happen. So 1 became 2, and then 2 there was just happening once, and this was, so this is a very simplified way of how the counting of words in a particular document actually got done in a MapReduce framework. Although the Apache Hadoop ecosystem was popular, using the distributed file system HDFS was tedious as is required. Most of the MapReduce was written in complex Java MapReduce programs, right? So it wasn't possible for all developers to access it. So many tools came out to ease this process. The popular ones were Pig, that came out from Yahoo, and Hive from Facebook. Okay. So this table sort of shows you the difference between Hadoop, Pig and Hive. So Hadoop is a compile language. So it's a much lower level of abstraction. So in order to write code for doing data processing in Hadoop itself, you needed to write a lot of lines of code in Java. More development effort was involved, but code efficiency was very high. Pig was one of the high-level languages. It was a scripting language, so it did higher level of abstraction, comparatively less line of code than MapReduce. So you didn't have to write the MapReduce program in Java. So development effort was less, but code efficiency was relatively less as well, right? Again, Hive. So Hive was developed by Facebook. Hive is a more SQL-like query language. So it also was a higher level of abstraction. So what it means by higher level of abstraction is you write all your processing as a SQL query, so that the Hive framework will convert it into internally into the MapReduce paradigm, right? So comparatively less line of code than both Apache Pig and MapReduce Hive resulted in. So development effort was much lesser. Of course, coding efficiency was relatively less as well. So revisiting the Apache Hadoop ecosystem itself. So we talked about the HDFS, right? And then this is your what is called YARN, which is yet another resource navigator. And then we talked about MapReduce. So you can think of these levels as, so this is the file storage. HDFS is the file storage. And then this was the resource scheduler essentially. And then the MapReduce, where you had to write the program as a Java complex program, or you could write your program using what was called Mahout or Hive or Pig. So of the three, I know that Pig was the most popular of it. So within the Hadoop ecosystem, there was Storm, which was used as a for streaming data as well, right? And then Zookeeper is yet another resource allocator, right? That were helped in essentially scheduling all of these jobs. Because there were too many of these separate components, so when Spark came about, it came about as a unified way of dealing with big data processing across any kind of workload, so that you don't have to write any complex MapReduce algorithms. So you can just do your programming in high level language itself, and Spark sort of takes care of converting it internally and doing all the cluster management for you. So coming back to Spark, Spark is a software framework to process big data. So it is a distributed data processing engine. So one of the very key fundamental data structure in Spark is called the RDD, which stands for Resilient Distributed Dataset. We'll talk a lot about this, how Spark inherently manages data. So it does not have a storage system like Hadoop HDFS. So you need to have a storage platform. So you can have your data stored in HDFS format or any other BigQuery. So data can be actually read into Spark. So Spark is a data processing engine. It supports many programming language, although initially it was written using the Java and Scala, which is closely related to Java. Today you have PySpark, RSpark, where you can write your program in Python or R as well. The Spark ecosystem consists of a Spark core which is a general execution engine, and then it has 4 libraries built on top of it. The Spark SQL is a component on top of Spark core that introduces a new set of data abstraction called Schema RDD. The Schema RDD provides support for both structured and semi-structured data. Right. So then you have your MLlib. MLlib is a rich library for machine learning algorithms, and it contains a lot of classification, clustering, prediction algorithms. It includes a few low-level primitives as well. So Spark also comes with a library to manipulate graphs, which is the GraphX. Right. So GraphX extends on top of the Spark RDD API. And then you also have the Spark streaming for that allows for real-time streaming data. It provides an API to manipulate data stream that matches with the RDD API. So we're going to talk about Spark core, and then probably look into definitely the SQL and the MLlib, and as time permitting, looking at the other libraries. So now that we have understood Apache Spark, let's take a look at some of its features. One of its greatest feature is its speed. It does computation in memory. So Spark enables application running on Hadoop cluster to run 100x faster in memory and almost 10x faster when running on disk. So it has an advanced DAG execution engine. So DAG, as you all know, is directed acyclic graph that supports acyclic data flow. So we'll look at all of these when we start coding on Spark. Another very key feature of Spark is its generality. So it's considered as a unified engine. So it's designed to cover a broad range of workflow. So it's a general programming model for developers to write an application by composing arbitrary operators. So it makes it easy to combine different processing models seamlessly in the same application. A very quick review of the different types of data processing. We have talked about it before. So there are batch processing, which process large volume of data all at once, and it requires dedicated staff to handle issues. And then we have talked about your stream processing. So it analyzes streaming data, cross-device data in real time. The data output rate must be as fast as the data input rate. Majority of the enterprise workloads that we see are usually batch processing. So batch processing is very popular in enterprise. Of course, depending on the nature of data you will have stream processing as well. So other than that, you have real-time operating system where it reacts to data in seconds or milliseconds, right? So this is more so when you are collecting data in real time. Stream is where the output rate is as fast as the data input, whereas real-time operating systems are where you're just processing data. So you're getting data from a particular sensor, or let's say you have a digital twin factory where you're getting data from multiple sensors when a factory is in operation, right? So you have to still crunch a lot of data, but the output rate need not be as in the same way. So truly real-time operating system becomes a little bit difficult to implement. So most often there is enterprises try to do it as a pseudo real-time. So depending on how often data needs to be processed. So you can think of doing a pseudo real time as, hey, doing batches over very smaller time intervals, right? Instead of waiting for doing it at the end of the day or so, you can do it every hour, right? So that you can get a sense of real time, or it can be done maybe twice an hour, etc. So I'd like to quickly distinguish between Hadoop and Spark. So earlier we looked at Hadoop, Pig and Hive, right? Whereas Hadoop and Spark, with regard to the speed, so Hadoop is faster than any traditional system. Spark is much faster than your MapReduce. Hadoop is essentially written in Java, whereas Spark inherently is written in Scala, but you can program now in Python or R. So Hadoop is written as a batch processing engine, whereas Spark is a unified data processing for batch, real-time, iterative graph processing, as we have seen. With regard to ease of use, Hadoop is complex and lengthy. Even despite having tools such as Hive and Pig, it does become a little bit tedious to work in the Hadoop ecosystem, whereas Spark, it's compact and easier than Hadoop. With regard to caching, Hadoop does not support caching of data. Caching is essentially some sort of data sharing that happens, whereas Spark caches data in memory and enhances the system performance. So in this slide, we are going to take a look at the Spark architecture. The Spark architecture is a master-slave architecture that consists of a single master node plus multiple slave node. Okay, so there is a driver program that runs the main function and executes the parallel operation on the worker node. So you essentially write your program, which becomes your driver program. So the driver program manages all the worker nodes. So the master slave takes care of the cluster manager that acquires and allocates resources required to run a task. So you just have to write your driver program. So the driver runs the main function and executes parallel operation on the worker node. The results of the operations are collected by the driver back. The worker nodes read and write data to and from the data sources, right? So they have their own access to the data source. The worker node also cache transform data in memory as RDD. Worker nodes and driver nodes is executed as virtual machine in public cloud. So you can set up your Spark architecture. There is also managed Spark architecture that we will be used for coding. So this is to give you a quick look at the Spark ecosystem as against the Hadoop ecosystem. So there is the storage layer. So data can be stored in a Hadoop distributed file system, HDFS, or it can be Amazon S3, local storage. So it supports both SQL and NoSQL databases. You can have your Postgres as the storage itself. Then on top of it is the management layer. So Spark clusters can be managed by Hadoop Yarn or the Spark cluster manager. Then you have your engine, which is your Spark core itself. And then on top of it, as we have discussed, the Spark ecosystem consists of Spark SQL or Spark MLlib, Spark GraphX, or your Spark streaming. And programming can be done in Python, Java, Scala, or R. So it gives a lot more flexibility. So this is to give you how the Spark ecosystem differs from the Hadoop ecosystem. Alright, so to summarize this module, so we got introduced to the Apache Spark framework. We took a brief look at the Hadoop ecosystem for processing big data because it helps to understand sort of how Spark originated among the Hadoop ecosystem. Then we looked at some of the specific aspects of Spark, it's the feature in terms of generality of the data processing engine and speed. And then finally we ended by looking at the architecture and the ecosystem. So I'll see you in the next video. Thank you.